My dear friends, today we are going to learn about current divider rule. So in this current divider rule, assume that already we know in the parallel connection, current is divided in the each parallel connection. So see this case, we have two resistance are connected in parallel. The current source current is I. It is divided as I1 and I2. That is called as current divider rule. So also we know in the parallel connection voltages are same. So that means this voltage across the resistance R1 is same as the voltage across resistance R2. Both are same. That's what I have written dV. Okay. So now we are going to derive the formula in order to implement this current divider rule directly when you solve the problems. So now in this case we know that this supply voltage, we can see this voltage is equal to current into the particular resistance. We know as per the Ohm's law. So now in this case the voltage is same. Voltage is same. Here also V and this voltage is also V. So therefore we have to find out what is the current in this particular circuit, total current. So how to find out total current? The current is equal to voltage divided by resistance. Current is nothing but voltage divided by resistance from this formula. So this, what is resistance? The resistance is nothing but the equivalent resistance of the parallel connection. Equivalent resistance of the parallel connection. I hope you understand. So now as these two resistance are in parallel, how to find out equivalent resistance? 1 by R equivalent is equal to 1 by R1 plus 1 by R2. That is equal to, we can take R1, R2 as LCM. Therefore here R1 plus R2. So from this R equivalent is nothing but R1, R2 divided by R1 plus R2. So this is the equivalent resistance formula that we have to substitute here. So from this, in this first equation, we know that what is equal to I is equal to, we can substitute directly, therefore V into, this will be the reciprocal will come here, therefore R1 plus R2 divided by R1 R2. So this is the total current in the particular circuit. So now we are going to find out what is mean by I1 and I2. Current flowing through the resistance R1, current flowing through the resistance R2. So how to find out current flowing through the resistance R1? That is nothing but I1. I1 is equal to parallel connection, voltage is same. This voltage is same. Therefore V divided by this particular resistance R1. Okay, particular resistance R1. So but in this equation will give V is equal to I into R1 R2 divided by R1 plus R2. This equation will give. So we can substitute this voltage here. So we can write I into R1 R2 divided by R1 plus R2. The into the this is 1 by R1. I hope you understand. From this I calculated V, and from this V I have substituted here. So we will get R1 will cancel. Therefore I1 is equal to I into R2 divided by R1 plus R2. So this is the current which is flowing through the resistance R1. Similarly, what is the current flowing through the resistance R2? That is equal to I2. I2 is equal to, similarly here I2, this voltage is same, parallel connection voltage is same, therefore voltage divided by R2. Voltage divided by R2. Already we know this voltage, I am substituting here. So I into R1 R2 divided by R1 plus R2 multiplied by 1 by R2. This 1 by R2. So R2 cancel. Therefore I2 equal to I into R1 divided by R1 plus R2. So this is called as current divider rule. How this, but in this case I1 and I2, we can see the difference. Whenever I2 is come, we have to write here R1 only, first resistance. Don't write, but in the voltage divider rule, whenever V2 comes, in the previous lecture, V2 comes here, R2, V into R2 divided by R1 plus R2. But when the current is come, for previous resistance divided by R1 plus R2, you can say V is equal to I into R, I is equal to V by R. If suppose for particular voltage is constant, we can say I is indirectly proportional to resistance. That's why when I1 come here, I1 current is inversely proportional to resistance. So in that, likewise you should remember I2 means here R1, I1 means here R2. So like that we have to substitute. Same way we have to find out what is the, in this three resistance are connected in parallel. When these three resistance are connected in parallel, we have to find, already we know this voltage across resistance R1, voltage across resistance R2 and voltage across resistance R3 all are same. Voltage across resistance R1, R2 all are same. So as like the same way, we have to find out first R equivalent. What is R equivalent? 1 by R equivalent. Both three resistance are in parallel. Therefore, we can write 1 by R1 plus 1 by R2 plus 1 by R3. If we take LCM, we have R1, R2, R3 is LCM. So we will get here R2, R3 plus R1, R2 plus R1, R3 plus R1, R2. That means from this R equivalent is equal to reciprocal of this. Therefore, R1, R2, R3 divided by R1, R2 plus R2, R3 plus R2, R3 plus R3, R1. So like that we can find out R equivalent. So now we have to find out what is the value of current I, total current here. What is the total current? Total current I is equal to V by R equivalent. I is equal to V by R equivalent. Total R equivalent. Already we know what is R equivalent. So we can substitute here. We will get this V voltage into R1, R2 plus R2, R3 plus R3, R1 divided by R1, R2, R3. R1, R2, R3. Now we are going to find out what is mean by I1. What is I1? I1 is equal to voltage divided by this voltage, first voltage divided by R1. From this we can find out what is equal to V. So let me write first this one. From this equation will give voltage is equal to R1 I into R1 R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. So to R3 plus R3 R1. So from this, what is I1? I1 is equal to V. From this V is equal to I1 V first resistance voltage. All voltages are same. Therefore, V is equal to I into I1 into R1. That is equal to I2 into R2. That is equal to I3 into R3. Since these three voltages, parallel connection voltage, all are same. So from this we can find out what is I1. I1 equal to V divided by R1. Already R1 calculated. Therefore I1 is equal to I am going to substitute this V here. So this R1 and this R1 will cancel. Therefore R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. Then I2 is equal to V divided by R2. Therefore I into R1 R3 divided by R1 R2 plus R2 R3 plus R3 R1. then finally I3 equal to V divided by R3. So R3 will cancel in this term. Therefore I into R1 R2 divided by R1 R2 plus R2 R3 plus R3 R1. So these three formulas will be helpful to find out the current flowing through the each resistance by applying the current divider rule. So in this case also, whenever you calculate the resistance current flowing through the resistance R1, then R1 will not come. Only in the numerator R2 and R3 will come. So I into R2 R3 divided by R1 R2 equivalent resistance. Similarly, whenever calculate I2 in the numerator I2 will not be there. The remaining resistance, multiplication of remaining resistance will be there. So I into R1 R3 divided by equivalent resistance. Not equivalent, R1 R2 plus R2 R3 plus R3 R. For denominator all are same. When this I3 comes, here R3 will not be there. R1 R2 divided by the numerator, denominator will be R1 R2 plus R2 R3 plus R3 R1. Likewise, we have to be calculate for various values of various problems. Directly you can substitute the formula. This is for 3 resistance are in parallel. Then this is for 2 resistance are in parallel. Likewise, you can do the problems. The next class I will share the some shorts related to solving the problem. I hope this topic is very much interesting and understandable. Those who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.